Let's learn more about the chain rule. Let's practice a little bit more. I have copied the statement here for you. So we have it here for reference. Let's now compute capital F of x equals the second of x to the 1/2. X to the 1/2 is the square root of x. So I could write it as the second of square root of x. And the second is 1 over the cosine. So if I wanted, I could write 1 over the cosine of the square root of x. These are different ways to write it down. Now, this is the composition of two functions, f and g. Okay, my f is the second, and my g is x to the 1/2. All right, so f prime of x, we take first the derivative of the outside function, the second. So the derivative of the second, I'm sure you remember, is the second of x times the tangent of x. Okay, this is one of the trigonometric functions that we need to know the derivative. Okay. If you don't remember, you can always use the quotient rule, 1 over cosine of x, and just do it. Okay. So this is, notice here that this is the second of x, but here in the chain rule, it's the second of x to the 1/2. So this is going to be the second of x to the 1/2 times the tangent of x to the 1/2. Okay, this is the derivative of the outside of f evaluated on the inside function g, and now multiply by the derivative of g, which is x to the 1/2. And this is 1/2 x to the negative 1/2, or if you want, 1 over 2 square root of x. Okay. So we can leave it as it is. 1 over 2x to the negative 1/2, the second of x to the 1/2, the tangent of x to the 1/2. And this is the derivative. Okay, we can simplify it more. We can write x to the 1/2 as square root, many ways. Okay. One thing that is important to realize is that we can combine the chain rule with the product rule or the quotient rule. Okay, there are no limits there. For example, let's say we do this function f of x, that is x to the power 4 plus x squared plus 1 to the power 10 times x to the power 8 plus 2x plus 3 to the power 12. So there are two ways we can do this. We can expand the power 10 and the power 12 and multiply the two polynomials, and that will take like the rest of the semester. Or we can just use the product rule, right? Say, okay, this is the derivative. Let me copy paste. The derivative of the first times the second plus, and now is the first times the derivative of the second. You see that it gets a little messy. And now you have two choices. You can decide to do the two derivatives here. You can do them on the side and then plug in the work, or you can just go for it and do everything in the same line. Let me show you how that's done. So then the first derivative here is something to the power 10. So the outside function will be the power 10. So this is 10 times the basis to the power 9 the basis is x to the power 4 plus x squared plus 1, and then times the derivative of the basis, correct? And now, of course, this, let me use colors here. So this is just the first part. So this will be this part. Okay, and then it goes multiplied. We need to remember that it was multiplied by something else. And then we take the second part. Okay, remember there is a first factor, and then I don't need this, this is what I want to compute. Then this part here, let's use a different color, let's say red. For this part here, what I get is, so 12, the basis to the power 11 times the derivative of the basis, x to the power 8 plus 2x plus 3. Okay, are we done? No. We are not done because we still need to find these two derivatives, but then we will be done. So this is 10 x to the power 4 plus x to the power 2 plus 1 to the power 9 times 4x to the power 3 plus 2x, remember the parentheses, times x to the power 8 plus 2x plus 3 to the power 12 plus x to the power 4 plus x squared plus 1 to the power 10 times 12x to the power 8 plus 2x plus 3 to the power 11 times 8x to the power 7 plus 2. And this is it. Here we may decide we can clean up a little bit. Okay, notice that here we can factor out this polynomial here that appears in both terms. So always we try to simplify as much as we can, but within reason, okay? And then here, x to the power 8 plus 2x plus 3 to the power 11, that appears in both terms, okay? And then this goes multiplied by everything else. So it's 10 times 4x to the power 3 plus 2x times x to the power 8 plus 2x plus 3, because this is a power 12 and we are pulling out a power 11. Okay, I need more space here. Plus 12 x to the power 4 plus x squared plus 1, because this is a power 10 and we have pulled out the power 9. And then here we have the x to the 8 plus 2x plus 3 to the power 11 that goes out, times 8x to the power 7 plus 2. And we may want to try to simplify this further, but I would say this is fine. Okay, we can leave it here.